Hi dear students, let's see this question that came in KVPY 2019 SX Part 1 Physics paper. This is a nice question from the topic of electrostatics. So let's see what's happening over here. Basically, we have got a neutral copper sphere, okay, whose radius is 10 nanometers. Now we are slowly adding each electrons one by one, okay, and we have to choose the correct graph between the magnitude of the charge on the sphere and magnitude of the potential. Okay, so basically here they have given charge versus potential graph, but in my opinion it should be magnitude of the charge and magnitude of the potential. Why so? Because you can see when electrons are being added, so naturally the charge on the sphere will be negative, and the potential that it would acquire will also be negative. So that is why I'm saying y-axis represents the magnitude of the charge and x-axis represents the magnitude of the potential. So in each of the graph, it represents the magnitude. Now we have to select the correct graph. Okay. So let's see how are we adding the electrons. So remember, electron has a got discrete value, a finite value of charge. So we are adding charge discretely. So at any time, if the charge value of the charge is q, so we can say that potential will be is equals to kq by r, or we can say that q will be is equals to r by k into v. Okay. Now q of course will be in a multiple of electronic charge. That means at any time it will be one electron or two electron or three electron or four electron or five electron, like that. So if you draw the graph of q versus potential, so in my opinion, it should be like, q can have a value of 0, or it can have a value of 1 electron, or it can have a value of 2 electron, or it can have a value of 3 electron, or it can have a value of 4 electron. And correspondingly, the value of potential will can be found out by putting 1 electron, 2 electron, 3 electron, 4 electron in this equation. So basically you'll have to multiply n electrons by k by r, and you will get some value over here. Okay, so k is 9 into 10 power 9, and r is very very small. So this basically this value is very, r by k is very very small value. So actually this will be uh, this type of graph rather. Okay, which has a very very small slope. Okay, now the so basically you can see that the graph should have very very small slope, but that is not the concerning point. The concerning point is that in my opinion it should have dot dots, because the charge is being added in a discrete manner and not in a continuous manner. Okay, charge is not being added in a continuous manner because we are adding one electron at a time, so it is being added in a discrete manner. Okay, now if you go to the graphs, so definitely C and D are wrong, because Q versus V should represent a straight line. In option A and B, it is a continuous graph, and in option A, although this looks like a continuous graph, but in my opinion, they are trying to show that stepwise graph. In like graph A represents the stepwise graph. That means they are trying to show that charge and potential are increasing in a discrete manner, stepwise. Okay, but in my opinion, this should have been a better representation, like showing dots. Okay, so so this should have been the correct answer in my opinion, but I think the stepwise means discrete manner, like they are trying to show that charge and potential are increasing in a discrete manner by showing it in the stepwise variation. So the best option is still option A. Option B is definitely wrong because it shows a continuous variation, which is not the case here. The stepwise variation definitely these dots basically, so we can say that it's a stepwise variation. So it's like it represents that the charge and potential are increasing in a quantized or discrete manner. So this is option A looks best to me. Okay, so that's it. Thank you.